Almost ready to go, folks. Sorry if there's any slight delays today. I think we're running a little bit loud now. Clipped. Come on. That's not right. 1, 2, 3, 4. Getting a little bit out there. I clipped. I don't want to clip. I want to be audible but not clipping. If that is okay. Audible but not clipping. First time I've used this microphone with this setup, so apologies if there's any slight confusing aspects to it. And start up. There we go. What a day. We are almost ready to go. Just making sure I know what I'm going to talk about today. It's really a slightly shorter lecture today because this lecture was designed for the public holiday week, which was last week. But because of my travel commitments, I've flipped the lectures around so that we could do the data lecture in week 8 and then do this lecture in week 10. The week 8 lecture in week 9 instead, and then this shortish lecture here in week 10. But that's fine because I really want to focus mainly on the major project now. It's a good chance to chill a bit and just focus on a few external topics. All my streams are working. Restream is streaming, the regular stream is streaming. I hope folks can hear me. I'm just going to assume you can because I can see the dials. So if anyone can't hear me, you can just ping me, of course. Do that. Project. Music's a little loud. Well, that's because it's the intro music. I'll just get that down to minus. Minus 12. Is that a little bit less loud? Yeah, this intro music is, what's the intro music now? This is not one of mine. This is, I think, it's a piece called Neon Nights. I've lost the artist now. I think it was sort of a Creative Commons licensed work, but such a cool piece. A little bit of techno. I can't hear it actually. It doesn't monitor. I only get the. I can only see the dials moving. This one, I don't think it was not obtained from Free Sound. I wonder where it was from. I'll start the lecture in a second. I'll post a link to the music later. It should have been from Free Sound, but it was from a different website. Free Sound is the only one you're allowed to use. Okay, let's go back to the start. The start of this lecture and get things going. Oh, I've got to start my recording. I'll start this all again. Back to the intro. Start recording. G'day folks, welcome to COMP1720/6720. Here we are in week 10. I'm just going to pause my preview because I don't want my preview to show. Full screen, oh no, it's harder to pause your preview now. I'll just minimize OBS. It's weird having your face on the screen when you're trying to talk to a camera. You want to look at your face, so it's a hack to look on your, to hide your face so that you look at the camera instead when you're on Zoom or streaming like this. Now, we're in week 10. It's almost the end of the semester. We're in the last quarter now, the home stretch, which really means that we've loaded everybody in this class up with knowledge. You've done 3 wonderful assignments, and it's just so wonderful to see the cool ideas everyone has had in this class at all different levels of achievement. People are trying new things, no matter what level they're at, with P5, with coding, with artistic creation. I feel everyone's coming on a curve with me and leveling themselves up, which is just so fun to see. Now we're focused on the major project. We're in the final, turn this onto some kind of mode to stop beeping. We're in the final stretch, the final 3 weeks, where you should be focusing on starting your major project. So what are our admin works for the day? Let's make sure I haven't messed anything up down there. Admin messages from the day are to look at Lab 10 requirements. The Lab 10 is the lab when you are starting your major project. It is an exciting time to be here in 1720 because you're going to get started a full 3 weeks before your major project is due. Here's the requirements. You have to fork the repo. You have to start some aspect of your major project. You've got to commit it to GitLab, and then you've got to post it to the forum and bring it to your lab. So a little bit more effort is required to do this week's pre-lab exercise. And you must make sure that that is on the forum and brought to your lab in order to get those marks. That means that you're going to have to set aside enough time to do the forking, cloning of your major project, and actually making a commit into your repo. Why am I making you do this? Well, it is so important to start assignments early, and it's super important for a creative assignment like this to start having some ideas early so that you can iterate and talk to your tutors about it. Your tutors are here to help you do a great major project, and they will be able to give you feedback on your ideas over time if you let them. If you save all of your idea having for the 2 days before your major project, well, that basically falls on a weekend and no one is going to be available to help you. So the reason I'm making you start this now is so that everybody in the class has a chance to get some help from their tutors, no matter what level they're at. The tutors can give some great advice about what ideas they think will work, what ideas they won't think will work. Remember that every single one of your tutors has done a major project, or at least one major project in COMP1720 or 6720, and many of them have done other artistic projects as well. So they're people who have had the experience that you're having right now. Super important if you find the whole idea of open-ended artistic assignments a bit challenging, which many of us do, and that's totally fair. They are challenging. Art is hard. Sometimes I get comments in this course. Coding part is pretty accessible and easy, but art is hard. And I read those comments and I think, yes, art is hard. Art is hard, isn't it? I don't know, I'm looking over here to hopefully get an audience or something, but art is definitely hard. it is very, very hard to art. So you have to do your best to take the opportunities to practice, to iterate, and to work. As we were talking last week, the only rule is work, because that's the only way any of us know how to make good art. The only way any of us know how to do this well is to do the work, do the iteration, put in the effort. Unfortunately, no shortcuts for good art. Talking about a few little requirements-y things. I went through this on Friday, but I'm going to go through it again. In the major projects, you actually have three different... oh, we found it somewhere. Oh no, there's a link going on somewhere else in my team. You've got 3 different text files in your major project. That's not the major project, that's week 10. 3 different text files. And I'm going to talk about them all again today. You've got the artist statement. You know about artist statements. They've been in all of your assignments. And we've got 2 questions for you. How would you like viewers to perceive the major project theme in your work? So it's your chance to explain how you want someone to experience the theme. This is giving you the chance to meet this requirement. Relate to the theme in a meaningful way. That's a major project requirement. So you need to explain why someone will get the theme from your work. It's not just about you thinking of the theme as the artist, it's about how the viewer should relate to the theme as well. And how does interaction enhance the viewer's experience? Same question from assignment 3. You now are experts in advanced interactions, and you need to use interactions to enhance experience. So, making my screen a lot bigger. This is your chance to meet this 4th requirement and the 2nd requirement. Obviously, it's easy to meet this one. You just have to include interaction. This one is hard. You have to include interaction that enhances the viewer's experience. So you need to explain to us how you do it. You have to explain how you do it. So those are the 2 questions for your artist statement. You've got another file there, a file that you haven't seen before, called instructions.md. This one's not required. It's not for marks, but it's in case you've got something you need to tell us about how to use your artwork, how to set it up, what browser to use if you've got specifics that aren't Chrome, I guess, how to use a webcam, or if it needs a microphone or something. If there's anything about your artwork that you think we might not get intuitively, put it in that file. Even if you think we will get it intuitively, just put some instructions in there anyway about how to use your artwork. And we'll look over that quickly just to make sure that we've seen every part of your artwork, because when we're marking these, I don't want the feeling that I've missed something. And mainly what I'm doing when I'm marking is I sit there and have the experience of the artwork, and then I try to poke around and make sure I've seen everything, have a look in the code, make sure I've understood everything that the student has included in their major project before deciding on a mark. So it's important to make sure if you have some kind of secret functionality or little surprises, put them in there. I'll look at the artwork first, I promise, and then I'll look at the instructions afterwards, just to try to make sure I've got everything. So yeah, that file is optional. It's not for marks. It's just to help me and the tutors who are looking at your major projects understand what they're supposed to do, I guess. There's a 3rd file, the recent developments file, and this is what this lecture today is all about. This lecture is a recent developments in art and interaction lecture, art and interaction computing. So this file is actually only for COMP1720 students. If you're not a COMP1720 student, you can certainly put words in there, but I'm not going to read them because they're not required for your deciding on a mark in your work. If you are a 6720 student and you don't put words in there, that's not going to be a full submission, and it's not going to be evaluated as highly as if you had put the words in there. We've got some more slides in a minute that discuss those ones, but the first one I wanted to talk about was that instruction.md file. It's not the same as your artist statement. It's simply for explaining how to set up and operate your artwork, just in case it isn't intuitive or in case there are any special requirements. And this slide is about the statement of originality. So it's a word of warning really, because you've got more freedom with this artwork. We've been giving you more freedom with each one you've had to do in this course, starting with making a monster, making a workstation that was more broad, making an abstract artwork with sound that was very broad, and now the major project is quite broad except for the theme. And there are definitely people in this course who like to start with other code they find online and then change that, work it into their artwork. Totally fine to do that as long as you do two things. The first thing is change it significantly, and the second thing is put it in your statement of originality. So if you're taking ideas from somewhere else, they have to go in your statement of originality, even if you've significantly changed the code. If you've got ideas from somewhere else, it's usually pretty obvious to us evaluating your work that the code has come from somewhere online. If it's not in the statement of originality, that's automatically an academic integrity case. And really that just costs me several hours. I have to document the case, go through a form, have an interview with the student concerned. Depending on the severity of the case, usually in a first year course, if you're a first year student, it's not very severe, it's just you've made a mistake, and it's just going to cost everyone some time, really, and some frustration. If it's a situation where someone has been trying to hide some code, then the outcome can be a lot worse in terms of losing marks or failing a course. We certainly don't want that, but in most cases it's usually just like, well, someone forgot to put things in the reference. Well, they haven't done a very good job of their assignment then, because the references are an important part of the assignment. So I obviously take account of that in the evaluation. It's a certainly poor academic practice, but it's not academic misconduct. But I don't want to do any of these cases, really. It's much better for me if every time you are inspired by anything from online, you put something in your references, in your statement of originality. And the reason that I've asked everybody to get used to putting 2 references every assignment, at least 2 references, part of that is to make sure that everybody understands that the statement of originality is a good thing. It's good to have reference to other sources. It's good to be owning the fact that you live in a world and you see other things around you and you use code from online and you modify it and you take inspiration from it. All of that is good. None of this is wrong. So by putting those references in your file, you're doing the right thing and you're doing a good assignment. Of course, the other thing to remember is this change it significantly part. In the major project, just like the other ones, I'm sure I will see some folks who've taken code online and not changed it significantly to make some part of their project. Basically, when I see that, I'm like, well, that's kind of satisfactory, but it's not good in any way. So it's submissions that go down that path are probably going to be at maximum in the pass band, which is not great. I hope that everyone can get do a major project which goes above the pass band, is in the credit, distinction, or high distinction bands. So there's certainly risks about taking code directly from online and just using that as the main part of your artwork. If you've got any questions about using code from online, please ask on the forum. You can make anonymous posts if you want. You can ask your tutors as well. But it's really important to think carefully about how you're using sources online. Always reference things and make sure you're changing things significantly. And just like in all the previous assignments, if you use any asset files, sounds, images, fonts in your assignment, you must have those in your statement of originality. And they must have full author and source information. For assignment 3, unfortunately, I've seen a few sound files that have been cited just saying sound file from Freesound. Well, that's not a reference, actually. So that's actually not a good enough way of meeting that specification. So those students, a student who's done that, I've seen, that's going to get not as good an evaluation as if they had taken that reference and done it properly. Major project. Let's just talk about the context of your major project. Again, we've done this before, we do it again. We pretty much do it every week until the end of the semester. The goal. What's the goal? Your major project is an interactive P5 artwork for a new media art exhibition. Gallery attendees are able to walk around and may interact with your work. Your goal is to provide them with an engaging experience of roughly 3 minutes exploring the project theme. And this is what a new media art exhibition might look like. every computer having a different artwork on it, and people walking around, sitting down at computers and trying them out. And this was actually, back in the pre-COVID days, sometimes we would have an exhibition of COMP1720 in a computer lab, sorry, with a showcase gallery of all of the projects on the screen. All of the thumbnails are there, and everyone can click on the thumbnails and see different artworks on the screen. Really cool and fun, but a bit difficult to do in these COVID-ly times. So maybe we'll get back to that sometime, but sadly not this year. We will have an online exhibition though, so there'll be an online gallery for you to look at your project along with everybody else's project and see what people have done. The important thing here is the may interact part, may interact with your work. Because in this image, right, there's some people sitting around, there's someone interacting, there's some people having a chat, there's someone walking by. Your artwork really has to catch someone's eye. So we talked yesterday about hooks in advertising and in interactive experiences. So make sure that your artwork has some kind of hook that makes a viewer want to experience it. And if you don't do that, it's really not meeting the specification for the major project. You can interpret the theme however you like. You've got a lot of freedom here, but make sure you read the requirements carefully, because even though you have autonomy about the theme, you can't just do any program, interactive program, for your major project. It has to be an interactive artwork. So not a game, not a website, not like a planning utility or a word processor or a calculator. It has to be an interactive artwork that meets the requirements. So your task this week, this is your week 10 project. I've got your week 10 project here in the pre-lab task. The task is to make a start in your major project. So you have to make a start in your project and have some part of it finished for your lab in week 10. By your week 10 lab, we go through the affirmations. First week of positive affirmations. By your week 10 lab, everyone will have forked and made at least one commit in their major project. I will be checking. So positive affirmations, but also accountability. I will be checking to make sure everyone is doing that. Here we get up to the recent developments, going beyond and getting up to date. So we don't cover everything to know about programming or P5 in this course. We give you enough knowledge to create a great major project, and now it's the time to look beyond basics and have a look at what other people are doing in the field, the broader field of art and interaction computing, and how it might fit into your whole computing education. So why do we do this? Well, for most of you, most of my 1720 students, the point of this is to get inspired and to get engaged with what's happening in the world of interactive art. And the other point is to engage with the academic discussion. So your students at the university, I want you to be part of the scholarly conversation about this field, about art and interactive computing. I'm just going to turn myself down by a dB. Or two. I saw it peak. I don't like it. I don't like the sound peaking. Sadly, my gain control is all the way over there. A bit annoying today. For a 6720 student, the above is also true, getting inspired and engaged, but also it's actually a course requirement. So the 6720 learning outcomes include that everyone in COMP1720 has to relate their work to recent developments in the field of art and interactive computing. Course requirement, so you have to do it. This is why we have the recent developments file, because it's required for you not only to have a relation with recent developments, but to tell me what it is. So it's a very simple requirement here. If you're a student enrolled in COMP1720, then as an additional task, you must explain how your artwork reflects recent developments in art and interaction computing in your COMP1720 recent developments file, max 200 words. You don't have to write 200 words. You just need to answer that prompt. How does your artwork reflect recent developments in art and interaction computing? And obviously that's a tricky question because you may not have thought too much about recent developments. You might have been thinking about how to operate P5, how to do the assignments, how to interpret the theme. You've probably thought about some stuff which is a recent development, but you might not know exactly how to frame it. So today we're going to start and cover some fundamental concepts of recent developments, and we're looking at a few specific fields of discussion that you could look at in more detail. These are 3 specific topics that have good connections with P5, and we've actually already done one. We've already done data because I reordered the lectures to make that work. So the data lecture, data art, is already done. Now you've also got simulations and artificial life, and you've also got creative machine learning. Something's going on in the chat. Sorry, wrong chat. Simulations and artificial life and creative machine learning. So those are 2 things which are super interesting, definitely recent developments, and definitely a lot of cool artistic interactive work in those fields. So next week will be simulations and A-Life, and then week 12 will be creative machine learning, and today is this kind of overview. So what is the definition of a recent development? Something that happened in the last 15 years and is related to making artworks with computers that are interactive. So what we're talking about today starts in the late 90s, early 2000s area and comes right through to now, 2022. I've got some resources to help. The first resource are these lectures, every lecture since week 5. So if you're a 6720 student and you haven't seen all the lectures since week 5, now's the time to revise those. The second resource to help is this bibliography. I've got a link there, but it's here. The Art and Interaction Bibliography, a list of suggested references for this course. And these are broadly a lot of scholarly academic papers about different aspects of art and interaction computing that are worth reading and worth referring to frame your understanding of recent developments in this field. So there's some cool stuff here, creativity in A-Life, we'll talk about that next time. Generating albums with sample RNN to imitate metal, rock and punk bands. Talk about that in week 12. The art of interaction, talking about that today. Towards a synthetic acoustic ecology, that's a bit of a next week topic. A graphical musical instrument, we've talked about the iamascope concept before, and people have been referencing that in their projects already. Technology affordances, bit of an older concept related to affordances. Bellow-based augmented guitars, that's something we'll talk about today. From rituals to magic, interactive art of HCI, another great general understanding of how interactive art fits into HCI, or human-computer interaction, which is a core field of computing. Sound art, origins, developments, and ambiguities, a great reference. Thor Magnusson's Designing Constraints, really cool paper about musical interactive systems. Understanding musical predictions with an embodied interface for musical machine learning, another week 12 topic. The list goes on. I've got a lot of papers here. I probably could add some more. It's certainly a long list, but it's something that I expect all master's students to be able to look in a reference list, start to read the titles, understand what's going on, follow the links, scan some, just quickly read some journal articles or skim through them to figure out if there's any relevant information and take it from there. So that's a core academic skill that I expect master's students to be able to do. Of course, many undergrads have those skills as well, but it's expected for the master's students. So get on it. Here's your list and get reading. So now I'm going to frame a bit the point I was making before. How does interactive art and computing fit into the whole world of computing that you might be experiencing in a computing degree at ANU? Well, it can fit as a part of human-computer interaction, which is the study of how humans can use computers to accomplish tasks. Computers don't really exist in the world without humans to use them, so we have a field of study related to how humans use computers and what different applications can do to help humans do things that they want to do. And one of the ways that people have investigated human-computer interaction is to use interactive artworks as a way to push interactions further. So an interactive artwork allows us to have, or I guess, play and extend the concept of interaction and really understand how humans have positive experiences. So not only are interactive artworks like super cool and amazing in and of themselves as a contribution to culture and just humanity being great, but they also allow us to do some science and understand how people use computers. So this is what I'm talking about in the next few slides, a balance between the science of HCI and the artistic and creative goals of interactive art and computing. So in HCI, there's been a move from the earlier way of framing HCI, which was all about ease of use, usability, and that's actually what we call second wave HCI. First wave HCI was called ergonomics, which was just how, like, does a keyboard fit your hand and how far is it to move a mouse a certain distance, working on the kind of engineering measurements for how a human could interact with a computer, making sure that everything is the right size and shape, and making sure that it's the time required to accomplish an action on a computer is as fast as possible. Then second wave HCI was about ease of use, making sure that computers are not just don't just fit a human body, but they're easy to use or intuitive or usable for the task that they're designed. Then the third kind of wave of HCI is looking more broadly at how humans and computers fit into the world, looking at experiences. So when I ask you questions like how do you expect a viewer to experience the theme in your artwork, that's really an HCI question as well, as an artistic one. Because I'm asking you how a human is going to understand a computer system and interact with it. So, creative interactions. There have been some movements within HCI from tools that are for work to tools that support creativity. And this is a quote from Ernest Edman's book, 2018, The Art of Interaction. It's available freely, so go and download that book and read it. It could be the textbook for this course, really, but it's just a reference text. There's a move from routine work and productive concerns to human and creative ones within HCI. So that's what we're thinking about now. How does HCI and creative applications relate? Another entrant into this field is a researcher called Ben Schneiderman. And Schneiderman et al. Had a 2006 publication about creativity support tools, computational tools that support human creativity. Just give me a second, I better cough and come back. Sorry, I was trying to clear my throat. I've had a terrible time with my throat this semester because of my toddler in childcare bringing home every cold in the universe. So here are the 12, are they 12? No, 11 concepts for creativity support tools. And these are, you could think about what you make in your major project and think about whether your project meets some or any of these requirements for a creativity support tool? Does your project support exploration? Does it support many paths and many styles? Probably doesn't support collaboration. That's not really what we're talking about in this course. Does it make it as simple as possible and maybe even simpler? That's an artistic concept. Would you invent something that you would want to use yourself? That's something that I think about a lot in terms of creating an artwork. If it's an artwork that's designed for someone else and you don't like it, maybe it's not going to work very well. So you should probably make artworks that you like to play with and you find rewarding and interesting. Iterate, then iterate again. Again, this concept of iteration and making. And here's an important one. This one goes around a lot. Became a really popular phrase. Low threshold, high ceiling, and wide walls. What does that mean? The low threshold means it's easy to get started with a tool. So you walk up to a computer system, it's easier to start using it. The high ceiling and wide walls mean that once you start using it, you've got very wide possibilities of what you can create. So you provide a tool that lets someone get started easily, start making something simple, but doesn't limit them when they want to make complicated things. So is it possible to apply that in your major project? I don't know. It's a question for you to answer through your process of designing your interactive experience. So another concept that was explored in this Creativity Support Tools HCI Nexus is treating an artist as a creative power user. That's a quote from Linda Candy. Artists show us how to apply the excess of je ne sais quoi within a human-computer system. So they're showing us the boundaries and then pushing them a bit further. That's why we look at creative interactive tools in HCI. So studying interactive art gives us insight into the potential of a creativity support tool when in the hands of an expert. So you are now an expert in P5. P5 itself is a creativity support tool, allowing you to code a creative, interactive artwork quickly and easily and effectively. It has a low threshold, it has wide walls and a high ceiling. So you're the expert, and really you're pushing the boundaries of HCI with the artworks that you create. And Edmonds says that this translates into findings about everyday creativity. So when we study the process, study the artistic process that you're doing right now, we find out about how humans can be creative in the world. This is why I like teaching this course, actually. Not just because I want you to gain my knowledge, but because I gain knowledge from seeing what you do in your projects. Why am I telling you all this? This may seem like it's quite a different topic than last week. The reason is that interactive art, HCI, and the whole field of computing have important connections. Research about interactive art is often wrapped up in HCI research. And that third sentence is not a reason, but the other reason is that I want you to think of COMP1720 or 6720 not just as a fun elective, although it is an elective and I hope you're having fun, but as an important part of your computing education, because you're developing your understanding of how humans interact with computer systems. And if that's not core to how computers work in our world, I don't know what is, right? Computers don't just calculate things by themselves. They're programmed by people, they're operated by people, they're used by people. So in this course, you're studying that use through a creative lens and in a very open-ended way, but you're becoming experts in how interactions can be designed and experienced. Let's look at some interesting concepts. You've already looked at data art, and I hope that Brent told you about this one, the TreeViz artwork, a very now an old artwork, or a program really, but it's an artistic kind of rendering of how data works in a computer. And it's taken off. I'm sure everyone's computer has some kind of visual data storage visualizer like this, but a really cool idea from the 80s related to HCI and creative expression with computers as well. Sensors and hardware. This is something we don't talk that much about in this course, but you certainly have the capacity to use the sensors within a regular computer, the keyboard, mouse, webcam, and microphone. So the point of mentioning this is that art and interaction computing often includes pushing the boundaries of how a computer can sense human movements or activities. And this is one sort of example. This thing is a sensor that you wear on your arm, and it actually had little muscle sensors in each segment, and then it had a movement sensor as well. And this thing is a little computer, sort of similar to a Raspberry Pi. It's called a BeagleBone, and it's got this thing on the top called a Bella, which allows you to sketch up a musical interaction very quickly on the Bella, on the BeagleBone. So this thing is connected, and it was a artwork that I was working on with some folks in Oslo for exploring motion and music. And I'll show you a screenshot of the artwork in a minute. This is it. This is the performance with this Mayo and Bella setup. So 4 of us on the stage. There's me, and then my colleagues. And we were doing a performance where we had to be very still to make any sound. So it was a kind of backwards interaction. Usually you want a movement to make a sound, but this was a stillness performance. So if you moved a lot, the sound would disappear, and in order to get any sound, you'd have to be still and steady for a longish period of time. It would fade in over 30 seconds. And then you could slowly move, very slowly, just to have the sound change over time. Really fun performance to do. Another idea would be related to that project, was putting these same BeagleBone computers into a musical instrument and creating some kind of stillness musical interaction. So this was another project called Svarm Resonance with these guitars, and the guitars had on them a speaker at the back. So I was actually using these guitars as a big speaker. They had a speaker driver stuck on them, and the guitar itself would sort of sing with the sound of the speaker. Exploring again how people would interact with a musical instrument in a different kind of interaction than they're used to. Not a controlling interaction, but a kind of dialogue with that instrument, standing there very carefully, not moving. There was a distance sensor here on the top of the guitar that could sense how close someone was. So if they moved back and forth, the sound would disappear. Another broad field would be computational creativity. So broadly, we're talking in the previous slides and all through this course in how humans can create an artwork with a computer, but computational creativity is more about how a computer can create an artwork by itself or in collaboration with a computer. So the kind of main thing in computational creativity at the moment are neural networks that can create visual artworks, as well as sound and other media. But visual artworks have become really oversaturated now with computers. And this image is now out of date, but I found it last year. It's an image from an older neural network system or a combination of systems called CLIP and VQGAN for generating images from a text prompt. And of course, and this one, the example was images created on the text prompt of Australia. So what does Australia look like to this neural network? Of course, in the last year, we've seen a number of other systems, the DALI neural network and the Stable Diffusion neural networks that do the same thing. You put in text and it comes out with an image, except they do it way better. So there's just been an explosion of people trying out these systems and creating artworks, playing around with them to find something cool. And we'll talk about that stuff in week 12, really. Perhaps more related to interaction is this idea of a co-creative system. So working out how we can not just get computers to create works, but to work together with an artist, hopefully in real time. So this is an example called Exquisite Corpus by Sogwen Chung. where there were machine learning systems creating art, creating drawings, but they were represented with a physical robot. So there's the robot here. There's one little one and one big one. Sorry, it's probably behind my head. I'll get out of the way for a minute so you can see it. The other robot. And the artist would be on stage in a kind of performance art installation with some visualizations around them. I think there was sound, and then the artist would be painting or drawing on a big canvas, and these robots would also draw. So building a co-creative system and then creating a performance artwork around it to examine it in real time with an audience there and really focus on these interactive concepts. Another recent development, immersive technologies. And we looked at a few, I guess I showed on the screen briefly a few examples of virtual reality artworks yesterday. So this is something we do a lot of work on in my lab here at ANU, working with virtual reality and augmented reality. These people here are wearing a augmented reality headset called a HoloLens and interacting with an artwork over here, a physical sculpture. So this was a project to try to sonify sculptures and explore augmented reality interactions with an existing sculpture in the world. So this project was called Listening to Listening, because the sculpture here was called The Great Listening. This one actually is sitting at the CSIRO here on Black Mountain in Canberra. So we had different, or me and my honours student had different ideas about how to perform or activate a sound artwork that would sit alongside this sculpture, so that you could work with the affordances of the AR interface to activate that sound artwork, both moving around and maybe using a little user interface that you could see through the HoloLens. And then with another student, Yichen, who's one of the tutors we work with in this course and other courses, I've been designing even further augmented reality systems for outdoor experiences. Here's Yichen's work called the Sonic Sculptural Staircase here in the Hannah Neumann building. And then Yichen's now a PhD student working on new kinds of musical instruments using augmented reality and virtual reality systems. Another new kind of computer is the mobile computer. And this is something which has really taken off in the last 15 years since the iPhone gave us a powerful mobile computer with a great touchscreen that could really play back some exciting sound. So I've done a lot of projects. In fact, my PhD was about creating iPad musical instruments, and I'm still doing stuff related to mobiles, artworks, and music. This is an app that I created called MicroJam. It was an iPhone app that would let you draw on the screen and create little sounds that would go into a kind of Instagram reel interface, and other people could add new layers onto your sound to create a little composition. So a lot of fun working with that system. I also worked a lot with different kinds of mobile phone ensembles. There's me. This is about 5 or 6 years ago, here at the ANU in Llewellyn Hall, with some students from the ANU School of Music who are performing on iPads with me, exploring a new kind of musical interface that I'd created as part of my PhD, and performing a concert. Another kind of new computer which we haven't really seen that much of, but always has this extreme potential, is the idea of having robots that we interact with more often. We sort of wonder, or many researchers wonder, will robots become more of a part of our life? Are we going to rely more on robots to do tasks, drive cars, deliver food, clean our houses, look after kids, look after elderly people, keep an eye on us, keep us safe? There's all these ideas of things that robots could do, and artists have been exploring how to use robots in interactive artworks as well. So this is an interactive artwork by an Australian artist called Stellark, I've got another picture of it right here, which is a bit more, shows what this is supposed to do. Stellac was one of several robot artists who've explored a kind of digital twin or a dual of themselves in a robot artwork. So this work, I guess, was from the around 2010. That was when that particular previous slide was from. And the robot, this huge industrial arm, which is too dangerous to go near, so you have to have these big shields to stop people getting to it, would have a screen on it with a digital version of Stellac, the artist. One amusing note, this is an image of this from an exhibition in Sydney, and this is me. So you can see me there from 12 years ago as a freshly graduated master student from ANU. And then another weird note, this is a guy I actually ended up working with many years later in Norway, who I didn't meet at that conference, but he was there. Anyway, just wild things happen in the world of art and interaction computing. I've actually looked a bit at how robots could work too, because I worked in a robotics lab with some engineers. I was working on artistic and musical problems, but I always wanted to create a robot as part of my work. So I made a very simple robot that had one little arm. This is the little arm that the robot can move, and this one is an input sensor. So you can move one little arm to control some sound, and then if you stop, the little robot will move its arm to kind of wave back at you, create some sound as well. And this was all built on Raspberry Pis and neural networks to make this work. So I've got it around here somewhere, but it's kind of out of action. Oops. There's two versions. This is the little version with a screen and the original version with no screen. So I need to do some work to get these guys waving again. Whoop. So that's my, I'm out of ideas of different recent developments for today. We'll continue our recent development look next week with a look at artificial life and bio-inspired processes in P5, which is one of the funnest things, really. So if you're interested in that, feel free to skip ahead to the week 11 lectures. And then the week 12 lectures, we'll look at how to do some machine learning within P5, which is certainly a super exciting thing to get involved with. Someone's just asking where the streaming link is. Like, I don't know. I don't know what to tell you. Isn't it on the lecture stream tab? Yeah, it's there. It's on the lecture stream tab. You can find it. Or they can find it. It is there. It's good to help people find their lecture an hour in. Yeah, what was I saying? Week 12, ML. Everyone wants to know about machine learning, right? So why not combine machine learning with P5? And that's what we're going to do in week 12. A lot of fun. And talk about some computational creativity as well. We're now at the point where I'm going to do a little demo of something. We've talked a bit about objects, but I haven't given you the full story of objects, really. Because so far we really just looked at objects in this sort of way. Let something equal, you know, prop. Is this an object? I think I'm doing it wrong already. Where was my objects? We had it basically as just a list of properties within curly brackets, which is all well and good if you only want to create one object. But if you want to create lots of objects, it's better to have a thing called a constructor. So there are actually many ways to create objects in JavaScript. Many ways, some of which I don't understand, but if you want more info, you can look in the MDN docs for the full details about all objects. Whoops, that's drawing. The MDN docs, working with objects. This will give you the full story. There's our classic object design that we would normally use. So there's our object, my car, 3 properties, make, model, and year. And we're setting this. It's all constant. We're not making any new objects here. We're not going to be able to make any new objects apart from that. But this is our, I guess, the classic Pokemon object, Sally. We can make a special function which generates objects called a constructor. And so you mark a constructor in your code by having a capital letter at the start of the function. And once you've done that, you get to start, you get a function which returns an object rather than returning a number or an array or nothing. So we'll make a function for making a Pokemon. Pokemon, what were the 3 things in my species, level, HP? Level and HP. So you've probably, if you're a computing student, you've probably seen object constructors before, because they would have been more typical in Java, in COMP1110. But in JavaScript, you don't need them. Someone's asking me if this is shorthand for creating a class called Pokemon. It's not, because JavaScript doesn't really have classes. So I think you're thinking about this through a Java lens, where objects and classes are really important. If there's anything called a class in JavaScript, it's like a weird extra way of thinking about things. I don't believe as by default JavaScript supports something. It does though, I know it does though, but like it's not the main thing in JavaScript. Yeah. I'm just arguing with Melody in the in the team. But what I try to do in this course is, rather than doing like every single extension in JavaScript, all the stuff that TypeScript gives you as well, I just want to do the most vanilla JavaScript I can think of that will work with P5. So we're not talking about classes today. Look, I'm happy to be wrong if I'm wrong about something with JavaScript, but I do try to do things the simplest, most vanilla way possible. Where was I? Oh yeah, function Pokemon Java. So Pokemon species level HP. So we're going to make a Pokemon now, and the way we do that would be let Sally equal new Pokemon. So we need to have the new keyword to say that we're activating a constructor. And then Sally's going to be a Pikachu. I'm going to be level 37, and I'm going to have HP 1,000,000. That's not so bad, is it? And so, how are we going to get this information into Sally? Because these things are coming in as arguments. And the way we do that is that we say this dot species. This is now, JavaScript knows that we're talking about a function, we're talking about an object, sorry. And this is referring to the object that we're now constructing right now. This dot species equals species. This dot level equals level. And this dot HP equals HP. Okay, so this should run. Doesn't do anything, but we can print out Sally and see what we get. Yeah, I know, I'm really messing up the balance. This mega buffed Pikachu here. There we go. So we got Pokemon a constructed function called Pikachu at level 37 with HP 1,000,000. And it's got a link to its constructor. So look, I'm not going to get into the class inheritance-y stuff in JavaScript. Someone else can tell me how that works, but it's weird. And it's not the same as your expectations from Java. Now, we've used this Pokemon constructor. What's going on with the new bit here? Well, new is a new special word, a special word that tells JS to create an object from a constructor. So if we don't have the new, I don't think it works. Let's take out the new and see what happens. Whoop. Doesn't work. So this function is not returning anything. So we need the new bit to make sure that JavaScript uses that function as an object constructor. Now, what's going on with this? I think I explained this already, but this is the special variable name in JS that refers to the current object that we're constructing or operating within. So we can use the Pokemon constructor to make lots of different objects. So this is the way of saying not that Pokemon, it's this Pokemon right here that we're making right now. And now this leads us to a way to add methods into constructors. And this is where this becomes especially useful, because our method, our function inside the object, can use this to refer to itself. So let's make this Pokemon say its own name. This dot species, or this dot, what did I call it there? This dot hello. That was a good name for a function. Hello equals function. I think that's the syntax there. I only look at this a few times a year, so I forget JavaScript syntax very quickly. And it's going to print, hello, my name is this dot species. That should work, right? Yep, everything's happy. We've got a hello function, and we're going to now use it. So I'm going to say Sally.hello. Hello, my name is Pikachu. So I've now got a function that creates objects. We're using the this, we're using the new, and we're using creating a function in line as a method. There are other ways to do this in JavaScript. They're more complicated than what I've just shown you, which is why I showed you this way. One more trick. So this is, I guess, one of the other ways of making a constructor. So suppose you've forgotten to make a constructor. Suppose you forgot to do it. So we've got this other Sally over here. Oh, we'll make another, this Pokemon is another one. Let Jennifer, sorry if there's any Jennifers out there who hate Pokemon. Jennifer is another Pikachu. And I wanted to make more Jennifers, but I've forgotten to make a constructor. I can certainly print out Jennifer, but there's only one Jennifer, and that is going to make things hard. But I can make more Pokemon with this statement here. Whoop. Let Jeffrey equal object.create Jennifer. So I'm making another Pokemon called Jeffrey. And I'm going to change Jeffrey's stats. Equals Charizard. And Jeffrey's HP is going to be really low. Sorry, Jeffrey. So we've now got a a Pikachu here and a Charizard there. So if we haven't made a constructor, we can still create lots of extra objects. If we have made a constructor, it makes object creation a little bit more easy to use, a bit of a better workflow if you're creating a lot of objects in your major project. And your major project might be where you want to make a lot of objects. And you might want to make a lot of objects next week in the A-Life lecture when we're making little creatures that interact in a more advanced way than we did before. So, well, objects by request. I'm not going to do any more objects, but I'm going to give you a few links to think about for the rest of the day. This is a really worthwhile book to look at. If you feel like reading a book, go and check this one out. It's the wrong record. I'll fix up that record link later. Go check out this book. Download PDF. Or just download some of the chapters. Did it manage to download the PDF? Anyway, it's super interesting. Here it comes. It's not a hugely long book. I think it's about 120 pages or something. Oh, less than 100. And it just has lots of cool examples of interactive artworks with different artistic systems, different references to different research that Ernest Edmonds has done over the years, working with different folks. So it's really worth a look if you're interested in how interaction and sensing and artworks can all relate and create some computing research. This other reference is Ben Schneiderman's Creativity Support Tools. This one is also worth reading, but it's not as related to like exactly making artworks, but definitely worth a read. Then finally, have a look at my art and interactive computing bibliography. So this is all we've got for today. I guess I'm going to look up this class thing. Melody, if you're still online, find the link to how to do classes in JavaScript, and we can just sort this out once and for all using classes. So this is what I was trying to mean, I think, or what I was intending to say, that you can use classes in JavaScript. They're not the main thing. I think they were added to JavaScript at some stage, and probably at a stage where I'm thinking, like anything that happened to you folks in like high school or before high school is like ancient history and doesn't matter, but it was like within my adult life that this was added to JavaScript. So I'm still not like okay with it existing. How do you use classes? I'm not going to disown anybody. I'll just go get that link over here. Here's how we do it. Class Pokemon. Yeah, sorry to derail Melody, but I'm still not used to the idea that classes exist, and I still think that they're like a kind of a hacked add-on rather than the main deal. In Java, you have to use classes. And in JavaScript, this prototype stuff, it's not as important of a concept. So here is a class Pokemon, and we've got a constructor function for that class, and then we've got a method for the class. Functional only all the way. Yeah, okay, we're going on a long discussion about programming language design. I'm not really a programming language design person, so if anyone has more information than me on the goodness or badness of these things, feel free to have those opinions, and I'm happy for you to have them. I'm an interactive art person at heart. Oh, annotate a method with const is the same as a static method in Java. Yeah, all right. I believe you. A lot of these things are very useful in some contexts. They're not terribly useful in a P5 making artworks context. What's a Pojo? I don't even know what's going on now. I'm going to end the lecture and try to keep up with the arguments happening in the chat. So thank you for joining me today. I will see you next Monday for our discussion on A-Life and bio-inspired P5 art making, which is a topic where I feel like I can speak with authority and not on the relative benefits of classes versus other things. So see you folks later. Have a great week.